Lung volumes and capacities. There are four volumes and four capacities. Four volumes first we will be studying. These can be remembered by LITER letters. Inspiratory reserve volume, tidal volume, expiratory reserve volume, and residual volume. First is tidal volume. Tidal volume is that air that moves into the lung with each quiet inspiration, and it is equivalent to 500 ml. Then is inspiratory reserve volume. Inspiratory reserve volume is air that can still be breathed in after normal inspiration. Means after normal inspiration, what extra amount of volume we can inhale. Then expiratory reserve volume is similarly the air that can still be breathed out. Means after normal expiration, how much extra we can breathe out. Then is residual volume. Residual volume is air in the lung after maximal expiration. RV and any lung capacity that includes RV cannot be measured by spirometry. Residual volume means how much residual is remaining after the maximal expiration. Okay, so 5 volumes we have understood. Then we will be saying the capacities. Capacities are sum of two or more than two physiological volumes. First of all, inspiratory capacity. Inspiratory capacity is air that can be breathed in after normal exhalation. Means how much we can breathe in after normal exhalation. After normal exhalation, inspiratory reserve volume plus tidal volume that we can breathe in, and how much extra we can breathe in and how much after normal exhalation. Inspiratory reserve volume plus tidal volume. Similarly, functional residual capacity. Functional residual capacity is volume of gas in lungs after the normal expiration. The volume which was remaining after the forceful expiration is residual volume, and after normal expiration means we have not expired forcefully, so extra volume will be added, so it is ERV. RV plus ERV. Then is vital capacity. Vital capacity is maximum volume of gas that can be expired after a maximal inspiration. Means here both are the maximum inspiration, maximum expiration. So three capacities will be added. One related to inspiration, one related to expiration, and one related to normal. That is inspiratory reserve volume, tidal volume, and expiratory reserve volume. Then is total lung capacity. Total lung capacity is sum of all the volumes, that is IRV plus VT plus ERV plus RV, that is equivalent to vital capacity plus residual volume. It is volume of gas present in lungs after a maximal inspiration. Maximal inspiration, how much volume is present in the lungs. Hopefully we have understood what are the definitions. Now we will be seeing from the graph easily how to know the values, that tidal volume is equivalent to this 500 ml, inspiratory reserve volume is equivalent to 3300 ml, then expiratory reserve volume is equals to 1000 ml, or residual volume is equal to 1200 ml. It seems somewhat difficult, but if we remember this graph, then we can easily remember. Like here graph is starting from 0, then it is going to 1.2, then it is going to 2.2, then it is going to 2.7, then it is going to 6.0. And we know the mnemonic LITER means first we will have inspiratory reserve volume on the top, then we have tidal volume, then we have expiratory reserve volume, then we have residual volume. So at the top we have 6 minus 2.7, that will be equivalent to tidal volume, that is 6 minus 2.7 3300, then tidal volume 2.7 minus 2.2 500, then 2.2 minus 1.2 1000, then 1.2 minus 0 equals to 1200 ml. So easy to remember, just remember the numbers 0, 1.2, 2.2, 2.7 and 6. Then lung capacities. Lung capacities we have already understood. First is inspiratory capacity. Inspiratory capacity is the addition of the first two volumes, that is I and T, IRV plus VT. That will be equivalent to 3300 plus 500. Easily we can calculate if we know the definition. Then is FRC, forced residual capacity. Forced residual capacity is ERV plus RV. Then is tidal Then is vital capacity. Vital capacity is Vt plus IRV plus ERV. That will be equivalent to, we can easily remember, 6 minus 1.2. That liters. Okay, then total lung capacity is sum of all the capacities. Then one main important point is, in the case of functional residual capacity, outward pulling force of the chest wall is balanced with the inward collapsing force of the lungs. Means in this, the outward force and the inward force is balanced. And if elastic recoil of the lung is eliminated, then after maximal expiration, volume of lung remaining will be, like we were saying that residual volume is air in lung after maximal expiration. And if elastic recoil is eliminated, then lungs will be collapsing, so minimal volume will be remaining in the lungs. So that's all how we have made this easy. I am hopeful that it will be easy now. Thank you.